am developing a software. So if I develop a software, I need to use libraries. I have a Python source code, and I cannot write anything without importing packages. Like for regular expression, I import RE. Or if I want to do kind of 3D graphics, then I import OpenGL. So if I am writing a source code, I am using classes from different libraries. What about documentation of the classes? So there are many ways. One way, I can just go to help prompt, and then I can see the class or the function doc string, so that I can know that what class does or what function does. Or I can go to kind of internet or somewhere where documentation is available, or through info page if it is available. I can read about the library, like what a class does. Okay, it's nice. What about if I want to know the kind of how classes are related to it? No. If I go to Python help, or if I go to any documentation, the relationship between class, okay, means the only way only way that I have is I can go through the library source code, and in the source code I can just browse through here and there, and I can see that which class uses what. It becomes very difficult in Python, where like languages like C++ or C, wherever we declare any kind of variable, we must place the type of the variable. It is int, or it belongs to a particular class. So if I see a function signature, from the signature itself I can say that this function accepts these classes. Okay, it's pretty easy. Means I can just browse the class, and I can see the dependency of the class on other classes. Inheritance is okay. Means in Python also you have to specify the class. But what about the kind of other part of the code? Like Python lives in three areas where we have module code, we have class code, and we have function code. Everywhere there is no typing. So life becomes really hell. Like suppose that I am writing machine learning code. I am using library Sklearn. So from the Sklearn there are many classes. Like I have classes in regression. I have classes in classification. I have classes in clustering. I have classes in dimension reducibility. And now every area they have n number of classes. If I go in Python code where type is not declared, it becomes almost impossible. In the first go it becomes almost impossible. Slowly we can go around. So it takes a lot of time. I mean, what I want to say is, you need to have a kind of a class design and inter-class relationship. So if this is available, class design, class or kind of module design, what are the classes available in a module? Then class, what are the functions available in a class? How classes are interrelated to each other? In a kind of a diagram, like, so it comes under UML called class diagram or package diagram, means module diagram. So if I get this kind of blueprint, this kind of skeleton, this kind of a pattern that is available in the source code. So rather than going all the part in the source code, just get the design part of it. Okay, so if I am using machine learning, then I have to install Sklearn. Okay, so Python 3 Sklearn is the package on Linux. And once I start using this package, then it takes days to understand the code and relationship between the class. So we are talking about reverse engineering. If I have source code, if I install the Python is kind of a language where you have the source code. Maximum source code is available when you install the package. So you have the package on your machine. You have all the Python files. Then it's just to everything is with you. So only thing remaining is that someone should just read the source code and draw the class diagram, draw the package diagram, and just you see the class diagram, and it should be crystal clear. This class derives from which class? This class has how many attributes? This class how many methods? This class is dependent upon how many other classes and those classes and so on. Yes, I can have a complete picture. So in reverse, so what we would do is, like if I have a C++, means I am writing C++ code, and I have installed C++ library, and I can start writing the code. Means I don't have the source code of the library. I have to purchase and what's. But Python is a kind of boon. Means you have everything. Means it's a kind of wastage of time if we don't draw the class diagram. Okay, so we'll use a tool called PyReverse. So PyReverse is a UML reverse engineering tool. It parses the Python code, it compiles it runs the Python code, parses the Python code, and it generates package diagram and class diagram. So we'll see that for the machine learning example, when we install the Python 3 Sklearn package, then how we can draw the reverse engineering UML diagram, like UML class diagram, package diagram, where we have all the UML notations. It's also called modeling elements. So in package diagram and class diagram, these two mainly it generates. And I think for a kind of one eye view, means when we see the code, just left side, if we keep the class diagram, it's so easy to write the code. Means we know now what it is. Or we can just browse through in mobile or somewhere. If I get all the class diagram, I can just browse through. And then I can have understanding about the software, about the library. So we'll see that how we can run PyReverse, that is a utility that is available in Linux, and that utility, how we can we can use this utility to generate class diagram, package diagram of a Python library. Especially we'll see in machine learning, Sklearn library, how we can do reverse engineering and we can generate UML. So that we will see. Plus, now there are, if I have a utility, certainly there would be, I won't say there are limitations in the utility. PyReverse itself is a kind of a small but highly effective utility. But generally people go for more. Means what about I want more? We have our kind of own utility that uses PyReverse, and it does many things. Like first it fixes the Python codes like PYX codes and PYX, PXI codes. And once the Python code is we generate into Py, then it just calls the PyReverse. It generates much better data. In the sense, like in PyReverse, it's not possible to, if I have a class, I can see its kind of its association, class containment, class composition, then class derivation, means extensibility. These things we see. But in PyReverse, we don't see the list of the classes that derive from a class. If I have a class A, then full class diagram of the A I can see. But if there are 20 classes that derive from A that I can't see, then I have to go somewhere and search, and then again, okay. So this is the kind of this is the way this class is derived from that particular class. Okay. So in our tool, we have extended the PyReverse, and we have our own utility, which would also add the derived classes. So if I have a class A, along with its class diagram, we can see the list of derived classes also. So that is one thing. Next thing is that what we see in the PyReverse is unnecessary classes are also present. Like there are few classes, they are huge in numbers. Their instantiation are huge in number. The association are too many. Their class becomes unnecessary big. It is not required. We can filter it out. So getting the list of the derived classes and filtering out the unknown classes. We have timeout also, like if I generate the PyReverse, sometimes due to some nasty classes, it may kind of just hang. It won't return at all. So in those cases, we have timeout. So we'll see the PyReverse, how machine learning library, it generates the class diagram. Then our utility that uses PyReverse, and it adds more to it. So that way. Further to the discussion on generating UML diagram through reverse engineering tool, we are using PyReverse. So we'll see on desktop, this is Linux Mint. Okay, so PyReverse is a kind of it's a reverse engineering tool. PyReverse is a reverse engineering tool. It generates a UML class diagram. It generates package diagram. So class diagram. So there are many diagrams in UML. So there are many diagrams in UML, and one diagram is class diagram, one diagram is module diagram, package diagram. So package is a kind of, if we have several packages, so package in Python, it can be a kind of a directory. We can give a status of a package, or anyway we have modules. So module can contain classes, a package can contain modules, a package can contain sub-packages, the way a directory contains subdirectories, a package can contain classes. So it generates UML class diagram, it generates package diagram. That is kind of amazing. There are many other diagrams in UML, like sequence diagram, and state diagram, and activity diagram, and there are so many. Time diagram. So when we talk about UML, the main concept of UML that comes into picture is package diagram. That is a kind of how the modules, package, sub-packages, they are aligned, how they use each other, how they are dependent upon each other, and after that, once we peek inside the package, then class diagram. So these two both are generated by PyReverse. That is kind of amazing. Okay, so what modeling elements we will see in these diagrams? So modeling element are the entities, the shapes that are available inside the module and class diagram. So we'll have kind of, it shows the generalization, inheritance, containment, aggregation and composition, use and dependency, and association. So these are the modeling element generally we'll find in the package and class diagram. Okay. Now, since we are using PyReverse tool, so we'll go through the installation. So PyReverse can be installed through sudo apt-get pylint or pip3. Okay. We will investigate sklearn package that can be installed through Python 3 sklearn. Sklearn code base is also available through Git hub. Okay, so this is the path of the Git hub. Once installed, if it is through package manager, then we can check through dpkg-l or pip3 list. How we can use? We can just type Python pyreverse -h for all this command. Pyreverse command line argument we can place, so -h to know the command line argument what it is. So module list we can provide like .py files or a package directory. Okay, so it is a package directory. Okay, so like package directory. Package directory. Okay, so module list or package directory. So module list or package directory, and then we have kind of we have levels of ancestors. So -a is for infinite level of ancestors, -s is for infinite level of association. M module wise what we want complete module path in the sense from the package to sub package to the sub package and to the module name, complete part in the dot format, package dot sub package dot sub package. So we want module complete path or we want only module name. So yes and no. K is for class skeleton, so there won't be anything inside the class. Only class name would be there, or -c for complete class description, all the attribute and methods. Okay. So if we don't want all ancestors, we don't want all associations, I can say -a and number of ancestors, number of association, -m complete module name, yes or no, and then only class name or complete class description. So this is the kind of signature or grammar of the PyReverse. Okay. So Python path, generally it's a good idea to set the Python path. I can say it is a must. So where our main package starts, that directory need to be set. So this is the example. Okay. So we'll start with installing the PyReverse.
Okay, so sudo apt get pylint. This is what is described. Sudo apt get install. Okay, it is already installed. We need to install one more package called GraphViz. So sudo apt get install GraphViz. Okay, it is already installed. So if I see dpkg -l egrep, so either pylint or GraphViz. Okay, so pylint in my machine it is 2.1.12, 2.2.12, and GraphViz is 2.42. So these are installed. Now we need a code base, so we'll use Python 3 Sklearn. So we'll install sudo apt get install Python 3 Sklearn. Okay, it is already installed and version is 0.23. Okay, 0.23. So I think we are done. Now I can go and create a directory. So I can say mkdir PyReverse Sklearn. Okay, so directory is empty. Now we'll proceed on creating what we have showed. So module list or package directory, and then this. So pyreverse -h we can type first, pyreverse -h. Okay, so these are the kind of command line arguments to the tool. Okay, so -f mode, filter mode. So if we use all, everything is visible, otherwise public only, and these things we can kind of provide. -c is for class, for a particular class. So -c if we use, then it will show all the attribute and methods. -a for ancestor, -A for all ancestors, -s for association, -S for all association, -b for showing the built-ins, -m for module name representation. If we want complete module name representation, we have to use y. -k only class names, methods and attributes won't show. Output format -o, colorized if you want classes and packages in color. Maximum color depth, to separate color up to the package depth, how much color depth would be there. If you want to ignore some kind of files that we don't want, -project to set the project name, and -d set the output directory path where the output would go. So it is set current directory only. So these are the options. So we'll say py. Now we'll see where our package is installed. So it is dpkg -l Python 3 Sklearn. Okay, so Python Sklearn code is installed in this location, where Sklearn code starts from here. So this is the main package, Sklearn. So we have to differentiate this. This is the installation directory, and this is our code from here. So this is the package. Okay. So we have to set the Python path to the library directory. So Python path should be set to here. We'll check if it is not set. kind of Python minus C import sys print sys.path. Okay, so it is already available, so don't need to set. Okay, now we'll run. So we'll generate package diagram the way we have stated, package diagram, then we'll see class diagram. So if I see this ls user lib python 3 dist package Sklearn. Okay, so we have in Sklearn packages we have so many sub packages. We have mixture, Gaussian mixture, and we have neighbors, we have neural network, we have SPM for classification, we have semi-supervised, and we have ensemble, we have decomposition for kind of reduction of the database kind of its dimension. Okay, we have covariance, so everything is there. Okay, so we can try kind of ensemble. Okay, so we have for the naive Bayes we have a module, but ensemble we have kind of all the kind of forestry and this kind of classification. It is available in ensemble. So we can say like PyReverse user lib python 3 dist packages Sklearn ensemble minus ASMY minus O PDF. I think it's now it is parsing all the modules inside this subpackage ensemble, and it will try to generate class diagram and package diagram. Okay, if it takes lot of time, then we'll reduce some parameter. So we'll see, kind of we'll wait for some 20-30 seconds. If it kind of hangs, then we'll use that. Okay, looks like it is kind of taking a lot of time. Okay, so I don't think it is a good idea to go for infinite level of inheritance and infinite level of association. So this is too big. So we will cancel this. There is nothing still. There is nothing. So we'll go back to the command, and now we'll force it to kind of single level of association, not the capital S, small s. We'll try again. Okay, so it should come. We have to wait. It should come. Okay, so I believe it should come. Okay, it came. Now we have two files. We have classes.pdf and packages.pdf. I can open packages.pdf. This is complete package diagram of Ensemble. So nice. Beautiful. Means we can see that Sklearn as Ensemble is the kind of the main package, and it depends upon these packages in the sense that it calls these packages. Okay, Ensemble stacking. Okay, that is a kind of Gaussian boosting GB. Weight forest. Okay, then Ensemble stacking internally use Ensemble base package. Very nice. So these packages, what we see, base package, stacking, these are module files. Sklearn Ensemble, it's a pure package. If it has init, then we can that also see like user local user lib Python 3 dist packages Sklearn Ensemble. Okay, so it has init files, and these are the kind of modules it imports from base is Ensemble, and this package is used by other. This is what we are seeing. So this Ensemble, it kind of uses these packages, and okay, so it uses these packages. These packages internally uses Ensemble base. So if I kind of open Ensemble stacking, okay, okay, so it imports many things. Okay, so we can see that it from dot base. So base is a package. From base it imports clone and so many things. Okay, so this stacking imports from Ensemble base. This is visible from this code. Okay, so it imports from underscores base also. Oh, it imports from here also. Okay, so this is package diagram. Which package is dependent upon which package? So panoramic, so nice. Okay, more can be investigated. Now we'll see the class diagram. Okay, it's a all classes available in this package are visible. Okay, every class has attributes and methods, and they are associated with other class. They inherit other classes. Association relationship, all it's kind of what is the annotation for the association or annotation for any kind of relationship that is mentioned in the green color. If it is visible, I think I cannot magnify more than this. So this is a kind of panoramic view of all the class diagram. It is amazing. I think it is bigger than this. Full class diagram of a package is available. Mind blowing. Okay, so what we can do now is, I am going to remove everything. So there is nothing now. We'll regenerate this and we'll use kind of colorized. So in color format, and we'll say -k. We don't want methods and attributes, kind of only a skeleton. We'll try to generate again. I believe it takes around 30 to 40 seconds. It should, I think it should return faster than what we did. So still we are at package level. Now after this we'll move to the kind of module level, and at module level we'll generate the classes. Finally we'll move to class level. Okay, so it should, I think it should return now. Okay, so it returned. It has again package and class diagram. We can browse package diagram. Okay. It is in color format, otherwise it is same, because there is no difference in the package diagram. It is colored, now it is green and like that. So it is same. We'll see difference in the class diagram. Okay, so in class diagram now we have coloring, and there is no there is no attributes, there is no methods in a class. So all classes are just for name has been printed. Now we can see like base. So I think our business is ensemble. So we have to find ensemble where it is. So class diagram is a kind of messy when we go from package level. I think somewhere it is. Okay, I don't think this is highly, okay, it's there. Sklearn ensemble GB loss function. And so this is coloring. Okay, I'll try without coloring again. So I'll delete everything. So this is the biggest point, that is the package. Once we move inside a module and classes, then it will be pretty fast. It is generating full package, so it is kind of we have to keep patience. We are not using color. I think it is coloring is very good. I mean, at class level or something, but at package level, it is kind of a little bit confusing. Okay, so I believe it should return now. Ensemble is I think it's a big package. We can go for a smaller package. Okay, it returned. So packages is same what we saw. There is no difference in the package. It is same. Now we'll see the class diagram. It is without. Okay, so this is class diagram, much prettier. And this is the derivation. And this is containment. So this is the class diagram without any property and without any methods. I think it is not highly useful because a human cannot understand this much correlations and these many classes. I believe no one can understand this much so well. There are too many and I think it is not highly usable. But whatever, at package level, we generated the class diagram and we generated the package diagram. Now we'll move towards a module level. So we'll remove everything. We don't have anything. Now we'll move. So inside ensemble, now we'll see kind of a forest.py. And inside forest.py, again we'll go with same parameter. Now we want full, not minus k. So I'll press enter. It should be faster. Okay, it is faster. Only class diagram. Okay, so at module level, we are getting only class diagram. Wow, this is really nice. Means all classes inside a module that we can see. Its attribute and its methods, everything. Okay, if I see the base forest the base forest class inside the forest, it has these many attributes, it has these many methods, and it derives from base ensemble, which derives from meta estimator mixing. So base forest derives from two classes, this class and this class, and in turn their other classes. Okay, and the classes which derives from the base forest is also available. There are two classes that derives from base forest, and for every okay. So this is module level. Okay, I don't want kind of this big picture. I want a small picture. This is pretty big. So I think I can remove this and we'll regenerate, and I would say minus k. Okay, I'll try with minus as my, all associations. We were using one level of association, all associations. If it hangs, if it doesn't return, then we'll go back with the association count 1. Okay, so it should not take too much time. After all, it's only a module. We'll wait for 20 more seconds. Okay, it doesn't return. So we'll cancel this. We don't have anything. So we'll go with our only single level association minus y. So we are printing only the class skeleton. We don't want property and methods. Oh, it returns. So it has class diagram. So nice it is. Now we have kind of a only class diagram, and all classes in the module is available, and how they are related to each other is available. Now we can see this arrow is for generalization, and this diamond is for kind of association or containment mainly. Okay, so green color is a kind of its annotation. So this is how it is. So this is a skeleton, and last time we saw the properties and methods also. Okay, so we saw the package level diagram, we saw module level diagram through PyReverse. Now we'll see class level diagram. So I can just grep kind of grep minus e, and whatever class we have I can just list down. User lib python 3 dist packages ensemble sklearn ensemble forest.py. So these many classes we have in this module. So any class we can see, we'll see base forest. Okay, so we'll type in the command my PyReverse user. I would remove everything. We don't have anything. PyReverse user lib python 3 dist packages sklearn ensemble forest minus a s m. We can try this, and minus c we want inside this module. We want class that is the base forest, and then we want output as PDF. That's it. Oh, it returned. Okay, so we have base forest.pdf. Okay, so this is what we are getting. Now we have base forest, and it derives from base ensemble and meta estimator mixin and base estimator. What is missing here? So missing here is we don't know what is derived from base forest. So if we draw the class diagram, then base forest derivation is missing clearly, but its ancestors are visible. Everyone class, everyone attribute and methods are also visible. If we don't like this, we can have only a skeleton. We can say we'll try minus k. Okay, we'll do same events. Okay, only a skeleton. no attribute and methods. We can try colorize, or we can try mn. What we had now is sklearn.ensemble._forest.base_forest. So full module path is there. Okay, so we can try mn. Since these are quick, so we can try all options here. It will return first. Okay, crystal clear. Only module name is printed, full path is not printed. Okay, so we'll print full path. We like full path. We'll make it colorized. We'll say show utils. No show utils. PyReverse -h. Show built-ins. Show built-ins. There is no show built-ins. Show built-in. Okay, so we have base again. Okay, now we have colors. Built-ins are in kind of light blue and classes are in, so we base forest derives from base ensemble in same module, and then other module in other blue, and like this. So this is we get through colorized. I can get complete colorized. Okay, so I don't want only a skeleton, I want complete. Okay, this is what we get in the colorized format. So there are two problems. If I draw class diagram, there are two problems. One problem is, if I am looking for the base forest, unnecessarily I am getting the attributes and so many methods for other classes also. So it becomes unnecessarily big. I am interested only in base forest. So I am interested only in these parameters, but I am getting so big diagram. So this is only for class. If I go for module level, if I go for package, it would become very big. So that is the one problem. Second problem is that if I am going for a particular class, then there is no derived classes are not listed. Only parent classes are listed. Only base classes are listed. Okay. So that is the limitation with the PyReverse. Okay. So two limitation. Third limitation is it doesn't work on kind of Python code. I don't know if there is a Python code here. So we can find dist packages sklearn star.pyx. Okay. Find dot name. Okay, there is no Python code here, But in the actual package, once if I download from JIT, there are Python code also. Okay, so these Python code are in SO libraries now, that anyway we are not getting the diagrams. But if we want complete diagram, then we have to look at the Python code also. And Python code is available here, so we can clone this, and we'll have Python code also. So I can clone this. So kind of git clone h .com SCIPY Sklearn
Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.